right, 9.6. We're going to talk about reductions, which this is a review from last chapter. Your author kind of likes to review things from chapter to chapter. The Grignard, we talked about a little bit what Grignards were, but now we're really going to get much more into them. Okay? So the review is the reduction part. All right? I want you to always remember that sodium borohydride and lithium aluminum hydride, or LAH, you should think of them as H negative molecule, as a hydride. Okay, because that's basically how they're acting. And remember, you can either take a ketone or an aldehyde. Ketone or aldehyde, I'll put an H down there. And remember, you can add either NaBH4, an acid, and form the alcohol. Or you can add LAH, an acid. Remember, LAH was much stronger. But for ketones and aldehydes, you can add either one. Sodium borohydride is the preferred because it's safer to use. So that's why people prefer to use that one. So this is a review. The mechanism, very simple. I think we kind of went over this last chapter. Your hydride, don't worry about the lithium and the boron or the aluminum or the sodium. Basically just think of it as a hydride. The hydride acts as a nucleophile. It attacks that partial positive carbon. It kicks up the pi bonds. So you get O negative, H, R, and then your second step is adding acid to protonate that O negative charge. So you formed an alcohol, and your H was your was the nucleophile. All right, the second part of this section, which is the most important part, is the Grignards. This is something that's relatively new. All right, there's two parts to this. The first part is making a Grignard, which that's what we talked about in a previous chapter. The second is reacting the Grignard. All right, Victor Grignard was a scientist back in the early to mid-1900s. He won a Nobel Prize for this. This is like so common and one of the most common reagents ever used. All right. So the first thing, how do you make a Grignard? You make a Grignard from an alkyl halide. So you have some sort of alkyl halide. I can put X here. Remember, X is either bromine, iodine, or chlorine. And you just add magnesium metal. Just the metal, just the element. All right. It's not magnesium. Magnesium usually has a 2+ charge. But that's when it's an ion. This is not in the ionic form; it's in the elemental form. So it's a silver solid. It's very stable. It's easy to use. What happens is the magnesium inserts itself in between the carbon and the halogen, and you form a carbon-magnesium bond. The X also attached. So magnesium is in between the carbon and the halogen. All right. Now you have a carbon that's attached to a metal. So what kind of bond is that? That's an ionic bond. All right? So since it's ionic, you have a carbon that has a negative charge. So your carbon has a lone pair with a negative charge, and your magnesium halide is the counterion for it. So basically, you can kind of ignore this magnesium halogen part of it because it's just the counterion to it. It just has to be there to stabilize your carbon negative charge. So this carbon is a very good nucleophile. All right. In fact, it's one of the best nucleophiles. And what you can do is you can take ketones or aldehydes. So I'll put the H down there. You can add whatever Grignard you want. Let's put R, NGX. So you first have to make the Grignard. Then once you have it, what happens is, remember, your R technically is a lone pair with a negative charge. So this comes in here and just adds and makes your carbon-carbon bond. So I'm going to put a box around this to kind of distinguish between the R groups that you just added. So here is the R group that you just added. And then your second step is adding hydrogen to protonate. I wish I had different colors, but unfortunately these pens do not. So you've made a carbon-carbon bond. Here's your carbon-carbon bond formation. Remember, that's the holy grail of organic chemistry. And then you protonate it. So you do two things in this reaction. All right, you make a carbon-carbon bond, or you extend the chain if you're a longer chain, but you make a carbon-carbon bond. And the second thing is you synthesize an alcohol. Synthesize alcohol. Your product is always an alcohol in Grignards, in most cases. Those are the ones that we're going to see in this. Okay, so if we do a real reaction, let's take an aldehyde. Let's add cyclohexyl Grignard. We'll put a BR there. Adding acid. I'm going to put this on pause. Why don't you predict what the product is? All right, so this is what the product should be. All right, so you've made a carbon-carbon bond, you've extended your carbon chain, and you make an alcohol. Basically, this carbon right here is coming in and attacking that carbon right there. So you have 1, 2, 3, 4 carbons. That fourth carbon now is attached to your cyclohexane. 1, 2, 3, 4, and that carbon is attached to your cyclohexane. All right, the magnesium, the bromine, and the hydroxide that comes from the acid kind of pair up, and that's what happens to the magnesium. But like I said, I don't really care about what happens to all the other stuff. All right? So, another practice problem. It's going to be more of a synthesis problem. I'm going to give you the product. Show me how to synthesize this by using a Grignard. Synthesize by using a Grignard. So you're going to have something here, and obviously you're going to have something here. So show me what you need to do to make this Grignard. All right, the thing about this problem is there are two possible answers. You can either make this bond with a Grignard, or you can make this bond with a Grignard. Okay, so there's two possible answers. If the benzene is the Grignard, so this is MgBr, then your reagent that you're reacting it with, your aldehyde here, right, so it's not going to fit in the box, so I'll just draw it above it, would be that 5-membered ring aldehyde, and this is acid. All right, let me redraw it down here. Sorry about that. So MgBr, you're going to react it with this aldehyde, that 5-membered ring. Basically, this carbon comes in, breaks the pi bond, and then you add in your acid. The other way you can do this is by reversing the order. So make this, actually use this aldehyde, the benzaldehyde, that's what that is, and add it to this Grignard, MgBr, and add acid to that. This way this carbon can add in there. So there's more than one way to make a Grignard. It just all depends on which bond you want to form. Okay, but if you're looking at an alcohol, okay, it doesn't matter what your alcohol is. Let's put R, alcohol, R. There's always two ways to make this Grignard. Either making this bond or by making that bond. All right, and based on your compounds, you have to decide which one you think would be easier in order to make. Okay? So that's what Grignards are. Grignards make carbon-carbon bonds. They're very important reactions. They're very useful. These reactions are more used than the acetylide reaction, the triple bond that we learned to make the carbon-carbon bonds. Grignards are much more used. They're easier to make, and they're easier to use.